So this next problem is showing you that as the distance driven on a car increases, the value of the car decreases. And I actually came up with some data similar to this when I was shopping for a car. A while ago, I was interested in a particular model of car, and I located a bunch of different ads. The cars had different miles on them, and then they had different values. And I worked out a little regression model similar to this based on data of ads on Craigslist or other car shopping ads, and worked out a model where I saw that some cars were close to the trend line and some of them were outliers. If we go into Stat Edit, I have put this data into L4 and L5. So I'll just make a note of that, L4 and L5. And I wanted to do this example because it's going to have a trend line that's going down. Now X, what is X? X is the independent variable. That is the distance driven, the miles on the car. Distance driven. And this is the price of the car, or the value in dollars. Distance driven in miles. Usually provide the units in parentheses after the title. So we're expecting something that looks like this. I do have my data ready to go, so I can go to second y equals, and I'm going to say that plot 1, I'm going to change it to be second L4, enter, second L5, enter. And that's going to be totally different numbers than the previous problem, so I need to be sure to do zoom 9 to reset the window. And that's pretty much what I expected, except there's this weird vertical line here. And that's my best fit line from the previous story, which I never showed you before. It's got way too many decimal places, which is a little annoying, but basically this is the regression equation from the baby weights problem. Anyway, I don't want it, so I'm going to do second quit and get out of there. And I'm going to look at the graph. That's a pretty nice graph there. Looks like a linear model would fit it pretty decently well. So I'll ask my calculator to find the linear regression equation. I'm using L4 and L5. And then I want to store the regression equation into vars y-vars function y1, and then calculate it. And this is giving me the equation. I'm going to go ahead and write it down before I lose it. So y is equal to negative 0.1254x plus 24.418. Oh, something I didn't point out to you is that when I put this data into my calculator, I got rid of the 3 extra zeros every single time, and that was just because I didn't feel like typing in all those zeros. So we actually need to say that the distance driven is in thousands of miles, and the value is actually in thousands of dollars. Now, if I had entered the data as it's provided here, then I wouldn't have to do that. But because, I don't want somebody thinking that this just is 150 miles on the car. So by changing my labels, I managed to not have to type in all of those zeros. But I'm going to have to remember when I'm interpreting this equation that x represents thousands of miles and y represents thousands of dollars. Now when I graph this, I get the regression equation showing up and it looks pretty good. And I forgot to write down what the r and r squared values were, so I guess I'll have to do the regression again. That's all there, and I'll just hit enter. Okay, so I have r squared is equal to 0.958, or about 0.96. So 96% of the variation in car value is explained by the distance driven. That's pretty extreme. You'd think there'd be a little bit of leeway for how well the owner took care of the car, or whether it had got some dings on it. But according to this model, those other details only account for 4% of the value of the car, and most of the variation in value is dependent on variation in miles. And then the correlation is negative 0.98. So very strong negative correlation here. And I think the only other thing left to do is to interpret the slope and y-intercept. Let me see if I wrote those out on the answer key. I did not. Well, the y-intercept is the car value when x is 0. So a car with 0 miles on it will cost $24,000 according to this model, and that's me rounding. And then for each additional, let me back up and use my different wording here. The car value decreases by negative $0.125 thousand. What is 0.125 times 1,000? Okay, so the car value decreases by $125 for each 1,000 miles driven. Sorry, that's so crowded there. Okay, so if I had entered all these zeros in, then I probably would have just had 125 there. But that's the interpretation of the slope for this example. And I think you have something similar to this in the online homework. The last thing I wanted to point out to you is that I have this data from the class survey, and this would allow you to potentially do some other investigations about whether there's a correlation between your age and how much coffee you drink, or how much you exercise and how much you sleep. And it's not clear when you look at this where would be the independent and dependent variables. So I like to just think about cooking up little theories. I could have a theory that the older you get, the more coffee you drink, and then I could see if that's actually true. If I had that theory, then I would be saying that this is why, and it depends on your age. I might totally be wrong cooking up that theory. A minute ago, I looked at exercise and hours that you work, and you could cook up a theory that exercise, how much time you have to exercise depends on how much you work. Like if you work too much, you don't have time to exercise. And it actually wasn't true, surprisingly. What I found was the more people work, the more likely they are to exercise, which was interesting to me. That was not what I expected.